Hello everyone, you are all welcome to lecture number 1254, and today's topic is very interesting topic, that is the reaction mechanism in organic reactions. So when we are talking of reaction mechanism, means it is followed by step in sequences where bond breaking and bond formation will be taking place. So this mechanism is observed, and here let me make it very clear. It is not just like that you are watching on television, all the images are coming, step 1, step 2, step 3. No. It is your billions of knowledge, experience, also your hypothesis, all these excellence are combined to follow, to observe the reaction mechanism. Here in the case of reaction mechanism, your very deep knowledge of chemistry is required, where you should understand all steps. Like some reactions, they will accelerate and there will be formation of product only in presence of catalyst. In other reactions, there is no need of any catalyst. In some reaction, you have to understand the stereochemistry of the substance, and these substances which are ready for reaction are known as a reactant. And what new product you are going to get after all the reactions, that is called product. So reactant is written on left side. This side is your reactant, and here it is product. When we are talking of reactant, it can be atom, it can be ion, it can be molecules. And these ions, atoms or molecules, they will follow step, transition step. Somewhere one species, maybe nucleophile, which is rich in electron, is going to attack, and the other group is going to leave. So where there is transition of formation of bond and breaking of bond, and then finally product formation will be there. So in that condition, the stereochemistry is playing very important role. For example, if you have benzene, and that benzene, if you want to convert into phenol, so it means that one nucleophile, for example, if you have benzene is this, and then you want to add one nucleophile, OS minus. So what reaction you will get the product, that is phenol. So phenol is your product, and here what will happen, it will come and attack here, and other group will leave, and in this way your nucleophilic, so it will be your nucleophilic substitution of aromatic ring. In the same way, like if another benzene ring you have and it is attacked by electrophile, this is your nucleophile, and this is benzene, and here it is electrophile, and here it is your aromatic benzene. Here I am not discussing much in detail about the reagents, because for example in the case of nitration of benzene or aromatic compound, here we are using concentrated sulfuric acid and concentrated lactic acid. For example, in this case what we are using, concentrated H2SO4 and then concentrated HNO3. So there is a big mechanism behind it. Why not dilute? Why we are using concentrated lactic acid and concentrated sulfuric acid? The reason is that the concentrated sulfuric acid in the reaction mechanism of nitration of aromatic compound benzene means it will play as a solvent, first thing. Second, it will play as a most powerful dehydrating agent. It will not allow the release of any water molecule in the reaction, because if there is any water molecule in that reaction mixture, nitration will not take place, because that water molecule will combine with nitronium ion electrophile and there will be conversion of lactic acid, so electrophile will not be available. So this is called reaction mechanism, and this reaction mechanism, because those chemists who are working in the lab, they understand the reaction mechanism. That's why if suppose somebody is not having enough knowledge, or he or she is having limited chemistry knowledge, he may think, oh, what is wrong in it? We can take dilute or concentrate, doesn't matter. No, it matters. That is called reaction mechanism. And then you will get again this nitrobenzene. This is your nitrobenzene. And again there is stereochemistry. What type of product you are going to get? Then there is stereochemistry involved of any molecule, whether it is axial, whether it is equatorial, whether it is para, ortho, meta, ortho para directing group, meta directing group, because electrophile will go always to meta position of benzene ring. Nucleophile will go to ortho para position of a benzene ring. So that is deep stereochemistry is involved. And here, unless the students they know the basic concept of reaction mechanism and atom stereochemistry, axial equatorial position, ortho para meta position, and at the same time exothermic, endothermic nature of reaction, energy to transition, activation energy is needed to start the reaction. So these are all very, very important factors involved. And here, let me tell you, chemists, who are chemists? Who are organic chemists? If somebody is asking a question, organic chemists are those people who are involved in transforming different type of matter into new amazing substances. Benzene can be transformed into phenol. Benzene can be transformed into nitrobenzene explosive. And the same benzene which is neutral is transformed into phenol, that is antibacterial acidic. And the same DNA, RNA can be manipulated by changing the functional group. So here, for reaction mechanism, the organic chemist must understand the role of different functional groups. For example, if I want out of benzene, benzoic acid. So benzoic acid, once you are thinking of, you are going to treat with carboxylic acid, carboxylic group, and then carboxylic group will be attached here, and you will get benzoic acid. So, out of only one substance, by reaction mechanism, understanding the reaction mechanism, only with benzene you can produce toluene, nitrobenzene, then carboxylic benzene, then benzaldehyde, so many products, and there are very important uses in medicine, in drug, and also in daily life. And today, in the year 2024, to my understanding, I have gone through the literature, more than 60 million organic compounds are floating globally. And with this, I can say, speed, expansion, and growth in 21st century of organic chemistry. The fastest growing branch of chemistry today is organic chemistry, drug chemistry, pharmaceutical chemistry, medicinal chemistry, color chemistry. And we are getting different products. We are getting all the lot of new amazing products. And we are expecting that if the same growth is continuing in 2100, maybe after some 70 years, we'll be having 5 billion, more than billion organic products. So this is the growth of organic chemistry, because organic chemistry is involved everywhere. In drug, pharmaceutical, food, petroleum. Your petroleum is all nothing but mixture of hydrocarbon. It's all organic chemistry with some impurities. Go to pesticide, insecticide. It's all salt, different type of organic compounds. So it's very, very important to understand the reaction mechanism of all these reactions. It's a very interesting topic, and it is having lot of growth in future. So here very clear picture I am showing the same reaction mechanism what I have discussed, taking the example of benzene. Here the two reactions are shown, how nucleophile, that is OH minus, is coming to form the bond, and the leaving group hydrogen in the form of proton is going. So it will be, the reaction mechanism will be nucleophilic reaction, and the product you will get where the OH will be linked. In the second one, the same electrophile is there, and the ring is cyclohexane. And here the main aim is how to show that a reaction mechanism is there, that electrophile will be forming the bond and hydrogen will be breaking the bond. In this way you will get the product where electrophile will be attached. Here I am showing that is called lock and key mechanism, and this lock and key mechanism of reaction is all played inside our body between the enzyme and substrate, and how just like lock and key they are attached, and there will be lot of enzyme catalyzed reactions. So same what I have discussed is given in the form of summary. Number one, the reaction mechanism means step by step sequence of making and breaking of bonds and leading to overall chemical change, and matter is transformed into new amazing substance. Today 60 million products are there which are transformed in the form of organic substances, and by 2100 it will be up to 5 billion with the same growth of organic chemistry, that is fastest growing in 21st century. Number two, such steps of breaking and formation of new bonds cannot be seen or observed. It is not just like on TV. It is just your experience, your brilliance. Observed on TV, watching all steps of changing to product. Rather, it is our experimental skills and theoretical brilliance of knowledge of chemistry to understand such type of changes and formation of product. Number three, we know the reactive position of all substances in the form of reactants are either in the form of ions or in the form of atomic state, with catalyst, with stereochemistry. Only all these things, they are playing very important role in the formation of products. Number four, reaction mechanism expressed in terms of chemical equations derived from observation I have already told you that always reactants are written on left side, product on right side, and term condition after the arrow, whether it is reversible, irreversible, all those conditions. And I have given the example of benzene, how nucleophilic addition, substitution, or electrophilic substitution or addition is taking place. And here, let me make it clear that the reaction mechanism started even before Bohr model of atomic structure. It was in 1903. Bohr model came structure of atom in 1912. So in 1903, Dr. J.P. Lecture-1254, Dr. J.P. Lecture-1254, he proposed about the reaction mechanism of all these reactions, because there are conditions, and those conditions he called as a reaction mechanism. And according to him, reaction mechanism is very, very important to get the product, whether reaction will take place or not. So with this I will stop. Thank you very much for watching the lecture.